Hello and welcome back to the Core Learning channel. Today we're going to be looking at multiplying powers. Before you start the video today, some things that are going to be useful to know: expanding out powers and collecting like terms. So to start, the rule for multiplying powers: if we have a number a to the power of x multiplied by the same number a to the power of y, this gives us a to the power of x plus y. Let's look at a few examples. So first and foremost, we have 2 squared times 2 cubed. Using this rule, we add the 2 and the 3, and we get 2 to the power of 5. Now we have 3 to the power of 4 times 3 to the power of 5. Again, we add the exponents, so the exponents are the powers. So we have 4 plus 5, and that gives us 3 to the power of 9. We'll do 2 more. We have 10 squared times 10 to the power of 6. Again, following this rule, we get 10 to the power of 8. And lastly, we have a half squared times a half to the power of 3. Again, we just add the exponents and we get a half to the power of 5. So now we're going to look at how we derive this rule. So let's take an example, and let's go with 2 squared multiplied by 2 cubed to see why this rule is true. So 2 squared, well, this is 2 times 2. We have 2 cubed, this is 2 times 2 times 2. So the answer to the question 2 squared times 2 cubed, well, we take this 2 times 2, and we're going to multiply it by this 2 times 2 times 2. We can see that this gives us 2 times 2 times 2 times 2 times 2. And simply by counting up, we can see that this is 2 to the power of 5. So this clearly implies that the rule, when we're multiplying powers, is that we're going to add the exponent. So we can see we add the 2 and the 3 to get 5. If you ever get stuck remembering this rule, what I'm going to show you now is a useful way to try and derive it for yourself. So the first step of this method is we're going to find an equation, and this equation is going to take the form a to the power of x multiplied by a to the power of y. So a is going to be some number. So what I'm going to do is I'm going to take 2 squared times 2 cubed as the equation that I'm going to use to try and derive this. The next step is we need to find out what the answer to this equation is. So there's a reason I've chosen something like 2 squared times 2 cubed, because obviously for larger numbers this wouldn't be practical, but we're just trying to prove what the rule is. So we know that 2 cubed is 2 times 2 times 2, so we can just work that out to be 8, and we know that 2 squared is 2 times 2, and this is just 4. So the answer to the question, what is 2 squared times 2 cubed, is 4 times 8, and this equals 32. So now the next step, we need to work out what power of a gives the answer in step 2. In this case, our a is 2. So what we need to work out is what power of 2 gives us the answer to step 2. So what power of 2 gives us 32? Well, we can just work this through. So 2 to the power of 1 is just 2. 2 squared is 4. 2 cubed is 8. 2 to the power of 4 is 16. And then 2 to the power of 5 is 32. So the answer is 2 to the power of 5. So now we can pull this all together to show that when we have this question, 2 squared times 2 cubed, we worked out that this was 32. And then we worked out that that was equivalent of 2 to the power of 5. Using this information, this is enough to infer what the rule is. So we can see that the rule must be, when you have an equation like this, you have to add the powers together. So we can see we've got 2 squared and 2 cubed, so we add the 2 and the 3 to get 5 in the 2 to the power of 5. Now I'm going to go over a number of different types of questions you might get that involve multiplying powers. So for a few of these, what I'm going to do is go over an example first, and then I'll have a number of questions for you to have a go at yourself. So we have 8 questions here. Based on what you've already learned so far in this video, you should be able to answer all of these questions so far. Pause the video and then I'll go through each question individually in a moment. So the answer to the first question, we have 2 to the power of 5 times 2 to the power of 7. So in this case, the exponents are 5 and 7. So we just add those together and we get 2 to the power of 12. For the next question, we have 4 to the power of 4 times 4 to the power of 3. Our exponents are 4 and 3. We add these together and we get 4 to the power of 7. Our next question, we have 10 squared times 10 to the minus 6. In this case, we have 2 and minus 6 as our exponents. So I know I've thrown in a negative number here, which may confuse some people, but you just follow the same logic. So in this case, when we add these together, we have the exponents as 2 plus minus 6. That gives us 10 to the power of minus 4. So we have 2 minus 6 is minus 4. Moving on, we have a third to the power of 5 times a third to the power of 5. This gives us a third to the power of 10. We have 3 squared times 3 to the power of 4. This gives us 3 to the power of 6. We have 6 to the power of 6 times 6 to the power of 6. This gives us 6 to the power of 12. We have 100 squared times 100 to the power of 0. So again, this is just going to be the exponents of 2 and then plus 0. So we just get 100 squared. Lastly, a little bit of a tricky one, we have 2 to the power of minus 1 times 2 to the power of minus 2. So again, we have minus 1 plus minus 2. This gives us 2 to the power of minus 3. So the next set of questions we're looking at are going to concern multiplying powers, and it's going to combine this with collecting like terms. So I'm going to run through an example to show you how to answer this type of question, and then there'll be a few for you to have a go at yourself. So let's have a look at the type of question we could be answering, and I'll run through how we would solve this. So we have 2x squared multiplied by 2x cubed. So let's pull these terms apart using the collecting like terms methodology. So we have, from the first term on the left hand side, we have a 2, we have an x squared, then we have on the right hand side another 2 and an x cubed. So what we're going to do is move all the number terms to one side and all the x terms to the other. So we take across the first 2, we take across the second 2, then we take across the x squared, and then we take across the x cubed. So when we multiply all this together, well, 2 times 2 is just 4, and then we have x squared times x cubed. So we just, for this part, use the rule we've been using so far. So we've got x squared and then multiplied by x cubed. So these are multiplying powers. So we're just going to add the exponents. So we have x to the power of 2 plus 3. That gives us x to the power of 5. Bringing this all together is 4x to the power of 5. So now I've included 4 questions for you to have a go at yourself. If you understood the previous question I just went through, you should be able to answer these. So have a go. I want you to pause the video, and then when you're ready, unpause the video and we'll go through each of these questions. So hopefully you've had a go at these, and we'll now work through these one by one. So starting from the top, we have 3x cubed times 3x to the power of 1. Well, let's move our number terms over to the left hand side. So these will be the 3 and the 3. And we'll move our x terms to the right hand side. So this will be the x cubed and the x to the power of 1. 3 times 3 is 9. And then we have x cubed times x to the power of 1. Using the rules we've discussed so far, we simply add the exponents and we get x to the power of 4. So the answer you should get for this is 9 times x to the power of 4. Sorry. On to the second question. This time we have 3 different types of terms. So we have a number term, we have an x term, we have a y term. So again, we'll just have number terms on the left. So we'll have 3 times 3. Then in the middle we'll have our x terms. So this is x and x squared. And then on the right hand side we'll have our y terms, which is y squared and y. 3 times 3 again is just 9. So that's our number term done, 9. Next we have x times x squared. Again, we're just going to add the exponents. So something I've done here, when we have a number, so for instance, when we just have x, this is equivalent to x to the power of 1. Same with y. It's equivalent to y to the power of 1, but you may see it written in this form, so you need to know what it means. So in this case, when we have x times x squared, you're thinking, well, what am I adding? We have something plus 2. In this case, the something is 1. So it's x to the power of 1 times x to the power of 2. So we add 1 and 2 using our rule to get x cubed. And then we have y squared times y. Again, this is y squared times y to the power of 1. We add the exponents and we get y to the power of 3. So your answer for this one should be 9x cubed, y cubed. Moving on, we have 5 squared x cubed times 5x to the power of 4. So in this case, we have our number terms, which are the 5 squared and the 5. And then we have our x terms, which are the x cubed and the x to the power of 4. So there are a number of ways you can do this in terms of your number term. So using the rules we've been using, this is equivalent on the left hand side to 5 squared times 5 to the power of 1, which if we use the rules, we add the exponents, and this will be 5 to the power of 3. That's 125. Then our x terms, we have x cubed times x to the power of 4. We add the 3 and the 4 as the exponents, and we get x to the power of 7. So you should get 125 x to the power of 7 on this one. Lastly, we have 4 squared x cubed y times 4 squared x squared y squared. Now, this looks like quite a lot, but we just break this down methodologically. Oh my god, I cannot say that word. And we should be able to solve this. So this is only going to be using the rules we've gone through so far. We have 4 squared times 4 squared. These are our number terms. Then that's multiplied x cubed times x squared. And then multiplied y times y squared. So starting with the number term, we have 4 squared times 4 squared. Using our rule, we add the exponents and we get 4 to the power of 4, which if we expand that out, that gives us, I believe, 256, if I'm not being an idiot. We have x cubed times x squared. Add in the exponents, that gives us x to the power of 5. And then we have y, which is y to the 1, as we discussed, times y squared. So we add the exponents of 1 and 2 and we get y cubed. So all in all, this gives us 256, x to the power of 5, y to the power of 3. So lastly, we're going to look at one final type of question. And this is when we have, we are multiplying two number terms, but they are not the same number. So as an example, let's say you're given this question, which is 2 squared times 4 squared. Now, obviously, you could just break it down as 2 squared equals 4, 4 squared equals 16, and work it out that way. However, using the rules, this may not always be simple, so it's good to know how to do this. So the way we answer this type of question is we're going to break down the larger number. So in this case, we have 4 squared. Now 4 squared is actually the same as 2 squared squared. So we can see we've got this 4 in the bracket, and what we've done is we've replaced this 4 with 2 squared because we know that 2 squared equals 4. What we can then do is realize, well, actually, if we're squaring 2 squared is 2 times 2, and then if we square something, we just do that twice, don't we? So we've got 2 times 2 times 2 times 2. Well, we can work this out. This is 2 to the power of 4. So we can actually rewrite this question as 2 squared times 2 to the power of 4. And using the rules we have, this is 2 to the power of 6. So we can see the way we do this is we need to get it so these numbers, these base numbers, are the same before we answer this type of question. I appreciate in this case you can do it, but obviously with larger numbers, it's not always going to be as easy as simply just expanding out the powers. So I've included 4 questions here, all of which you should be able to answer if you've understood the previous example I've just gone through. So when you're ready, pause the video, have a go at these questions yourself. On the right hand side, you'll see I've included the form that these questions should be answered in. So check before you're happy with your answer that these meet the criteria. Then when you're ready, unpause the video and I'll work through each question one by one. So hopefully you've got on with that all right. We'll start with the first question. We have 3 squared times 9 squared. So what I want to do here, I want to rewrite this 9 in terms of a 3. Well, I know that 3 squared is equal to 9. So I can rewrite 9 squared as 3 squared squared. If I work this through, I should get 3 to the power of 4. So my question actually becomes 3 squared times 3 to the power of 4. Using the exponent rule, I add the exponents together, and that gives me 3 to the power of 6. Moving on to the next question, I have 2 cubed times 8 squared. Again, I'm thinking I can rewrite that 8 in terms of 2 to some power. Well, I know that 2 cubed is 8. So I can rewrite 8 squared as 2 cubed squared. Working this through, I get 2 to the power of 6. So then my question actually becomes 2 cubed times 2 to the power of 6. Using the rule, I add the exponents together and I get 2 to the power of 9. For the next question, I accidentally revealed the answer, but we'll go through the methodology. So we have 3 cubed x squared times 27x cubed. I want to rewrite that 27 in terms of 3. I know that 27 is equivalent to 3 cubed. So if I use the methodology of collecting like terms, then I'm going to multiply the 3 cubed times 3 cubed, and that gives me 3 to the power of 6 using the exponent rule. And then with the x terms, I have x squared times x cubed. Using the rule, I add the exponent, so I get x to the power of 5. So my final answer is 3 to the power of 6, x to the power of 5. For this last one, I've put each part in brackets just so it's clear which x's are multiplying and which are actually terms in the question. So we have 125x squared y multiplied by 5 squared x cubed y squared, and this is multiplied by 25x y. So here we have a few different number terms. We have 125, 5, and 25. Now hopefully what you should be able to see is that these are all powers of 5. So 125 is 5 cubed, 25 is 5 squared. So we can rewrite this as 5 cubed x squared y in that first bracket. Second bracket we can leave as is because it's already in terms of 5. And then the last bracket we can rewrite as 5 squared xy. Now we just use the methodology of collecting like terms. So we put all our number terms on one side, all our x terms on another, and all our y terms on another. So addressing the number terms first, this is 5 cubed times 5 squared times 5 squared. So we have 3 exponents there. We have a 3, a 2, and another 2. Using the exponents rule, we just add these together. So 3 plus 2 plus 2, well that's 7. So our number term is going to be 5 to the power of 7. Our x terms, we have x squared times x cubed times x. Again, remember when we just have x or y, this is equivalent to the power of 1. Because obviously it just makes it a bit easier in terms of when we're adding the exponents together. It can sometimes be a little bit confusing and trip people up when they don't see a number as an exponent. So we have x squared, x cubed, and x to the power of 1. So our exponents are 2, 3, and 1. We add these together and we get x to the power of 6. Lastly, we have y, which is y to the power of 1, y squared, and then another y, which again is y to the power of 1. So when we multiply these together, the exponents are 1, 2, and 1. So we add these together and we get 4. So all in all, we have 5 to the power of 7, x to the power of 6, and y to the power of 4. So thanks for watching. Hopefully you enjoyed that. If you did, please like and subscribe. And if you have any questions, leave them in the comments and we'll try to get back to you as soon as possible. Cheers, guys.